the same reason that we needed to pass the pointer to n. Questions? Okay, so memory management. It's one of the bigger problems in C, and for the most part, you aren't going to have to deal with it in Objective-C. There are some small things you'll have to think about, and we'll get to that next week, but the malloc and free stuff that you're used to, you don't really have to deal with. So remember that we have our stack and our heap, and so all of our local variables are always stored on the stack. And this means that, say I call some function and it needs to like return some array to the function that called it. It can't just declare an array on the stack and return it, because once the function returns, that array is gone. That's the point of it being a local variable. The array is gone. So malloc, what that does is allocate space on the heap, and the stuff that's allocated on the heap survives past whenever the function happens to end, whenever that variable happens to go out of scope. And so what malloc and free are like manual memory management versus the automatic memory management of local variables. And something to keep in mind is that pretty much all objects are going to be like this. All objects are going to pretty much be mallocked. They're going to go on the heap. And so they're going to continue existing after the scope of that variable ends. But thanks to the new iOS Objective-C features, you don't really have to think about freeing that memory. So we'll see why that's really useful.
Does that mean iOS is garbage collecting?
Yes. So the new, it's ARC, A-R-C, is automatic reference counting, and it will automatically collect these objects for you. That was not the case 2 or 3 years ago. Yeah?
Maybe give an example of the time
When you don't want to use ARC? So the only thing I could really think of is like if you wanted to be really explicit about the, like, you want to fine-tune your program, overly optimize it to make it like run better, but that's probably not the best use of your time. You are already using Objective-C, which there are a lot of things that's not doing in the most optimized way possible. So pretty much any app nowadays is going to use ARC.
I was thinking in a way that like maybe would make your application more performant or something like that.
Oh, so an example.
Maybe like memory-intensive, like graphical games app or something.
It probably would, but it's not really worth even trying to optimize your app for that. Yeah.
If I use, for some weird reason, malloc manually in my iOS program, does ARC catch that too? Or?
No, it will not. You pretty much shouldn't be mallocing. I actually wonder, I'm not 100% sure, but I imagine it's already taking very strict control of what the heap looks like. And so if you start mallocing things on top of what it's trying to do with the heap, it might screw it up, but I'm not sure. You won't need to malloc. Okay, Objective-C. So C questions before we move on to Objective-C stuff. Yeah?
What about DL?
Oh, so that's, well, in C, you would need to use free. So anything you malloc, at some point during the life of your program, you should also free. In Objective-C, that's the thing. So things are going to be somewhat automatically allocated for you, and they will be automatically deallocated for you, as long as you adhere to some things we'll see next week. OK, any other questions about C before some Objective-C stuff? OK, so from our hello world in C to our hello world in Objective-C, there aren't too many changes. You'll see that it looks a lot like C in a lot of ways. Unfortunately, the first word has literally changed. So what do you think the difference is between include, like we used to say hash include, now we say hash import. So what do you think the difference is there? So hash import is smarter than hash include in that it will only import something exactly once. And so this used to be an issue with hash includes, like if you hash include a header file twice and you don't take special precautions in that header file, then you might duplicate some definitions of things and it won't compile. Hash import, no matter how, if I said hash import foundation dot, or like if I just copy and pasted this line, the second line wouldn't do anything. So hash import is just going to be more efficient in that way. And another thing that looks somewhat different is this @ auto release pool. So that's going to be something we deal with next week. That has to do with automatic memory management. And the one thing to note, and we'll also see it in front of the hello world, this @ symbol is a very Objective-C thing. So like if you see code and you see an @ symbol, you might be able to reason that it is Objective-C because you're going to see this all over the place. In case of the hello world, so normally we'd see just like string hello world. By putting the @ symbol in front of it, we are making it an Objective-C type string. More explicitly, we are making it an NS string. So we're going to see that in a couple other places. But now this @hello world is an object that we are passing to the nslog function. Let's actually run that. So what is the ridiculous? Oh, I have. So you will pretty much never need to compile at the command line. Because once we get into Xcode, that's going to pretty much be everything you need. But here, we have compiled that program. It's exactly the same as the one that we saw in the slide. And running it, we see something that looks like this. So we see the date, we see the time, we see main, and then this happens to be the process ID, and then something called the mock port that you don't have to care about at all, and then the actual thing that we NSLogged. So this is what NSLog does. You will probably be using NSLog pretty frequently in your programs to debug things. In actual released apps, you probably want to get rid of your NSLogs or have them wrapped in like debug type statements. Since once you're on an iPhone, you pretty much don't have access to anything that is NSLogged. I think theoretically you can like plug in your iPhone to your computer and see what was NSLogged, but that's rare. Like anything released to the App Store isn't going to have any of those. Okay, so this is our first exposure to an object, but it doesn't really feel like an object because we pretty much just put an @ sign in front of it. That's technically shorthand for creating a string object, and I think we'll see the longhand later, or we'll at least see many other objects that we're going to be creating. So useless side that just says everything so far has been the command line. Everything can be done at the command line. You probably won't want to do things at the command line. So Xcode is pretty comprehensive on all things Objective-C and iOS. You should be able to get it for free, and we aren't really going to go into the details of what all these different places in Xcode are. It's pretty overwhelming the first time you see it. The only things we're going to be using today, like it's going to look like 3 of them. So we're not going to be using utility area. The debug area is what we're going to use to see where our NSLog things are going to be printing. The editor area is where we're going to see our code. And navigator area, we're just going to see our files. And it also contains all this debugging support and stuff, but we're not going to go into that. So you could, if you have an iOS device and you want to actually install these apps to your iOS device, this was discussed last week. But you need a developer account. So through us, you can get a free account, but you are not able to actually put the things in the App Store. So if you want to put things on the App Store, you will want to get your own account, which is $99 for yourself, and I think like $2.99 for a company or something. So you can look up a lot more there. And these will be put online later. So the new data types in Objective-C, there's pretty much only two big primitive data types that you need to care about. So bool and ID. So